Hey Geometry, so continuing with our trigonometric ratios, we're going to do a bunch of sine, cosine, and tangent of different angles in these examples. And so we've got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That's always the case. So let me go ahead and give you what we often use to help us remember this. We call this SOHCAHTOA. It's the mnemonic for remembering it. You got to spell it right, but it's sine is opposite over hypotenuse, so cosine is adjacent over hypotenuse, and TOA, T is opposite over adjacent, SOHCAHTOA. And so you'll see that referred to sometimes, and that's what a lot of people use to remember it. It's, I don't know, just a funny word. And so we will use that to help us remember this stuff. So sine of J, this angle J, so sine J is going to be opposite over hypotenuse. So the opposite side is 12 over hypotenuse 20. And so if I did sine of J, whatever angle this is, it would be 12 over 20, which reduces to, I guess we can divide those a little more. Divide that by 4 and get 3/5. So 12 over 20, 3/5 are 0.6 if you're going to be doing it, as a decimal in your calculator. All right, so that's sine J, cosine J, and tangent J. So cosine is adjacent over hypotenuse. So the J, when we say adjacent, we're talking about the leg that's adjacent. When we're referring to the hypotenuse, we always call it hypotenuse. So the adjacent is 16 over 20, and that reduces to divide both top and bottom there by 4, and so we get 4/5. And then tangent is, and you'll notice that this is going to be our 3-4-5 ratio for this. So our tangent of J is opposite, so going opposite of J across from it, 12 over 16. And so we get 3/4. And so those are our three ratios. And this is our 3-4-5 right triangle. This is a multiplier of 3. This is a multiplier of 4. That's a multiplier of 5 if we multiply them by 4. We can do the same thing for L, and we'll see some of these same ratios come back. This is how cosine of, the complements the other angle works out to be the sine of the first one, and so on. So we've got sine, cosine, and tangent of L. So L opposite over hypotenuse, L going opposite is 16 over 20, which is 4/5. Cosine of L is adjacent over hypotenuse, so ca, adjacent over hypotenuse, 12 over 20, which reduces to 3/5. And then tangent, it ends up being the inverse of this one. Tangent of L is equal to 16 over 12, opposite over adjacent, which is 4/3. And so there are some examples of doing that. You can go ahead and try these first, and I'll jot these in. All right, so in this one, if we look at J again, so we've got sine of J is going to be opposite over hypotenuse. Sine is SOH, S-O-H, so opposite over hypotenuse, which is 24 over 40. When we look to reduce that, both top and bottom will divide by, let's see, make sure I get this right. So we divided by 4, that would be 6 over 10, which can go one more, so we can divide by 8, I guess, for each of those. So we get 3/5. And notice that we have the same ratio showing up. So what that means is this was actually the same angle, and it means that these are similar triangles. So we have that same ratio matching on those sides. This is another 3-4-5 triangle. Another one, we like those. We like those nice numbers. And so these are actually just multiples of, if we multiply by, what did I just multiply by? 8. So 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. So we have that 3-4-5 ratio between those sides. So we're actually going to see all these line up the same. We can verify it, but cosine J is adjacent over hypotenuse, 32 over 40. If we divide both those by 8, we get 4/5. Tangent is going to be 24 over 32. 24 over 32. And 24 over 32, we can divide both of those by 8 and get 3/4. And move on to L. Sine would be 32 over 40, opposite over hypotenuse, 32 over 40, which is going to match the cosine of sine, so it's cosine of the other angle, 4/5. Cosine of L is going to be adjacent over hypotenuse, 24 over 40, which is going to reduce nicely to 3/5. And then tangent is going to be 32, opposite over adjacent, 32 over 24, which is going to reduce to be 4/3, matching that one. All right, next one. I'll go ahead and get this one set up. All right, so this one we've got some radicals going on. It's going to maybe look a little messier, but might also clean up decently nice in a number of instances. So sine J, sine of J is the opposite over hypotenuse from SOH, S-O-H, so 36 over 24 root 3. All right, so we don't like the root 3 in the denominator. We also can reduce 36 over 24. So we can divide both of those by 12. So I'm going to reduce this fraction at the same time. And then I'm going to kind of simplify this out kind of at the same time. So if we divide both those by 12, this is going to be 3. I'm dividing the top and bottom by 12. So this is going to be 3/2. But I still have that root 3 in the denominator times root 3. And then we're going to multiply by another root 3 on top. All right, so we multiplied the top and bottom by root 3, so I can have that square root of 3 of the denominator. I want to rationalize the denominator. Don't want that down there. So that's just going to end up being 3 in the denominator. Square root of 3 times square root of 3 is just 3, which is then going to cancel with this 3. And so we end up with square root of 3 over 2. And so that's one here. And you might recognize that ratio from one we were looking at up here, square root of 3 over 2. So we're dealing with a 30, 60, 90 here. You may or may not recognize that yet. That's fine. But that is what this is going to end up being. And so we could eventually figure that out. All right. So then cosine of J is adjacent over hypotenuse. So this is 12 root 3 over 24 root 3. And notice that is double it. 12 root 3 over 24 root 3. So root 3 is actually, that cancels nicely. So we just cancel that. 12 over 24. We can reduce that to just 1/2. So cosine is 1/2. And so we're dealing with a 60 degree angle up here if you figure that out. And that's because all 30, 60, 90s are similar. And so this ratio is matching a 30, 60, 90 ratio. Tangent J is going to be 36 opposite over adjacent, TOA, opposite over adjacent over 12 root 3. So I kind of want to do the same thing. I want to do a couple of things. I'll go ahead and reduce my fraction. 36 divided by 12 is actually just nice. That's just 3. But then I've got that root 3 in the denominator, and so I'm going to multiply by root 3 on top and bottom. And so those are just going to become 3. Root 3 times root 3 is 3, which will cancel with this 3, and we're left with just the square root of 3, which is a nice number there. All right, sine of L, so now we're jumping to this angle, opposite over hypotenuse is that 12 root 3 over 24 root 3. We already did this once. It ends up just being 1/2. In fact, we'll do both of these. Cosine is 36 over 24 root 3. 36 over 24 root 3, and we've done that once before. That just simplified to, in the very beginning, square root of 3 over 2. And then this one a little bit different. Tangent of L is opposite over adjacent, so 12 root 3 over 36. So this ends up being square root of 3, and then 12 over 36, we can divide both in top and bottom by 12, and you just get 3. Root 3 over 3, which is the reciprocal of that tangent, as we'll see throughout those other ones.